Welcome to Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we'll be answering the question, what is a linear equation in one variable? Well, a linear equation in one variable x is an equation that can be written in the form ax plus b equals c. This is where a, b, and c are real numbers and a is not equal to 0. If a were equal to 0, you'd have 0 times x and your whole x term would just drop off. Then you wouldn't have a variable left for it to be a linear equation. It would become constant. So if you will also notice, this particular equation is linear because it has degree 1. So the highest exponent on the variable is understood to be 1, making it linear. And also notice that I underlined the word that it can be written in this form. It may not always look exactly like this, but if you can rearrange the terms so that it does, it's still a linear equation. Now let's take a look at a couple of examples that are linear equations and then a few that are not linear equations. So as you can see on the left-hand side of the screen, I've got examples of linear equations written. On the right-hand side of the screen, I've got non-examples written. So let's just remember that linear equations can be written in the form of ax plus b equals c, where a, b, and c are just real numbers. So it's pretty obvious if we look at this first example. We have a is 3, b is 7, and c is 9. Our variable is raised to the understood first power. So this is an example of a linear equation. Now the second one on the left-hand side is also an example of a linear equation. X is raised to the understood first power. And if I did a little bit of rearranging of my terms here, I could write this as negative 15x minus 45, so I'm subtracting the 45 off of both sides, equals 0. So my a would be negative 15, my b would be negative 45, and my c would be 0. This last example on the left-hand side is also a linear equation. So we have x being raised to the understood first power. If I subtracted 6.8 off of both sides, I'd have x minus 6.8 equals 0, fitting that mold of ax plus b equals c. Now let's take a look at the non-examples and try to understand why these are not linear equations. In this first example here, the x is squared, which automatically throws it out of the realm of being able to be a linear equation. This is actually a quadratic equation. So to be a linear equation, the variable has to be raised to the first power. That has to be the degree of the equation is 1. So this is a quadratic, not a linear. Now if we look at the second one on the right-hand side, it would appear that x is raised to the first power. However, x is in the denominator, and you'll find in videos on exponents that if we brought this x up out of the denominator into the numerator, then that would become an x to the negative first power, which also knocks it out of being a linear equation. And the last one, we have x inside of absolute value signs, which is a completely different function altogether. So this is also not a linear equation. So nothing on the right-hand side here represents linear equations. And all of the examples on the left-hand side represent linear equations. All right. Well, I hope that taking a look at these examples has helped you understand what it means for an equation to be linear. Once again, it can be written in the form of ax plus b equals c, and x is raised to the first power. If you have any other questions about how to identify linear equations, be sure to ask your Highlands instructor. Thank you.